I completed a meta-analysis to explore how different secondary compounds L-arginine and T-polyphenols found in nectar can affect the memory retention in honeybees. I believed that there would be a greater increase in memory retention in bees that fed on greater concentrations of L-arginine rather than T-polyphenols. However, after completing the meta-analysis, it was found that there was not a greater increase in memory retention in bees that fed on greater concentrations of L-arginine rather than T-polyphenols. Data analysis. This figure shows the effect of secondary compounds T-polyphenol and L-arginine at control, low, and high concentrations on the olfactory classical conditioning of the proboscis extension response, or PER, in honeybees. The graph compares the PER percent, which is indicative of memory retention. If the PER percent is bigger, this means that there was a greater memory retention. This is done for controls, lows, and high concentrations of L-arginine and T-polyphenol. The letters above the graph show whether or not there is a significant difference between the groups within the with p-values being less than 0.05. Looking at this graph here, it is evident that there is an increase in memory retention when B is fed on lower concentrations of T-polyphenol rather than lower concentrations of L-arginine. There was also no significant difference between the higher concentrations of L-arginine and T-polyphenols, therefore allowing us to conclude that there was not a greater increase in memory retention in bees that fed on greater concentrations of L-arginine. Furthermore, it is important to note that there is a statistical difference between the two controls, which could indicate that there is something else that could be affecting the data that is not being accounted for here. Why is this important? Plant-pollinator interactions are vital to the survival of our agricultural ecosystems, as they are essential to plant reproduction. Therefore, it is important to understand how different secondary compounds in nectar can affect not only the memory retention of honeybees, but also further explore how they can affect other pollinators. It is also evident that specific secondary compounds have different benefits on pollinators, as T-polyphenol and L-arginine had varying effects on honeybees' memory retention. So it is important to explore how different secondary compounds can have a positive or negative effect on pollinators. The data for T polyphenols was pulled from floral T polyphenols can improve honeybees' memory retention and olfactory sensitivity. Specific information was pulled from the second graph here, highlighted in yellow. This data shows the proportion of bees that showed the proboscis extension response 1 day after treatment and 24 hours after the bees were PER conditioned for control, low, and high concentrations of T polyphenols. The percent of bees that showed the proboscis extension response towards strained odors was calculated for bees that fed on all three concentrations of T polyphenols to see the effect on memory retention. The data for L-arginine was pulled from combined secondary compounds naturally found in nectars enhance honeybees' cognition and survival. Specific information was pulled from the graph on the right for the percent PER 24 hours after PER conditioning to see the effect of all three concentrations of L-arginine on memory retention. The concentrations for this paper were originally in millimole per liter, so I had to convert the L-arginine concentrations to micrograms per milliliter to match with the T-polyphenol concentrations. Once again, the percent of bees that showed the proboscis extension response towards strained odors was calculated this time for L-arginine for bees that fed on all three concentrations of L-arginine to see the effect on memory retention.